Hello everyone. So we have already seen the superposition theorem and the Thevenin theorem. So now we will look at the Norton's theorem. So Norton's theorem is relative to Thevenin's theorem. Okay, it is nearly the same. What did we do in Thevenin's theorem? We replaced the whole bilateral network with a voltage source and a resistance in series. In this theorem, what we will do? We will replace the whole circuit with a constant current source in parallel with a single resistor. So this whole bilateral network will be replaced with the constant current source. The value of current source we call that IN, Norton current, okay, and a resistance in parallel, okay, RN. So this is how it will be replaced, and R load will remain as it is, okay. So this is our linear bilateral circuit. That linear bilateral circuit we are talking about, okay. This linear bilateral network is replaced with a constant current source and a single resistance in parallel, okay. Linear bilateral network. Now how will you find Rn? Rn, Norton resistance, we call that Norton resistance, Norton resistance, and that will be Norton current source. This will be Norton current source, right? So how will you find Rn? It is same as RTH, nothing is different. Rn is equals to RTH only, okay. Rn is RTH only. It is the Thevenin resistance only. Thevenin resistance, and there is no difference between Thevenin resistance and Norton resistance. We will see the comparison as well. So there also you will get to know. So how to find Rn? Same as RTH. Apply VDC, get IDC out of it. VDC by IDC is your Rn. That's it. Okay. So your Rn is VDC by IDC with independent sources being nullified, right? Right. So we have already seen in the previous video, the complete analysis in the previous video only. Now how will you find IN? So what is IN? What was VTH? VTH was the open circuit voltage, right? VTH was open circuit voltage. What is IN? IN is short circuit current, okay. We can't highlight short circuit open circuit current because open circuit current is 0 only. So IN is a short circuit current, that is a function of input voltage and input current, or source voltage or source current, okay. So what is ISC? When load is short circuited, the current flowing through the short circuit part, the short circuit path, okay. When your load is short circuited, so the current that is flowing through that short circuit path is known as Norton current or the short circuit current, okay. So while calculating the short circuit current or Norton current, you would do nothing with the energy sources. You will keep all the energy sources intact. Voltage source will remain there, current source will remain there. No matter it is dependent or independent, you will do nothing with the voltage source and current source. The same thing we did in the Thevenin voltage as well, right? When we were finding the Thevenin voltage, we were doing nothing with the voltage source and the current source. So similarly, if you are finding Norton current, you will do nothing with the voltage source and the current source in the circuit, okay. And how will you find the Norton current? What are the steps? First, you will keep all the energy sources intact, and the second thing you will do is that you will short circuit this load and just find the current. So what you will do, like this is your linear bilateral network. You will do nothing with this linear bilateral network, okay. It will remain as it is, okay. Linear bilateral network, you will do nothing with that. Just one simple thing you will do, you will just short circuit this load, the load that you are having, you will short circuit that and you will find the current in it. So the short circuit current that you get will be equals to the Norton current. Okay. So now what is the equivalent circuit that we have already seen? So let's just assume your short circuit current is in this direction, ISC. And now you will be replacing this bilateral network, right? So the direction of current will be upward. Why is it so? Let me draw the complete circuit, then I will tell you. This is IN, this is RN, and this is R load. So this is your ISC, right? If you short circuit this should be the direction of ISC. So your direction of IN should be such that in R load the ISC current goes like this only. Are you getting my point? Your ISC is this, from up to down. So your current direction in bilateral network should be like this, so that your current goes like this only in the R load network. Are you getting my point? The current in R load is from up to down. So here I will make the current source like this, that my current goes in R load from up to down only. If the current in R load is from down to up, if the current in R load is something like this, so how will I make my IN? I will make my IN like this, so that this current goes on like this only. Are you getting my point? So IN should be made such that the current in R load goes from down to up. So that's the important point here. What should be the direction? Okay. So always when you short circuit the load, you have to remember that direction of the current should be from up to down. Then only you will replace the circuit with this current source. Otherwise, the current source will be in opposite direction. So from up to down, if the current direction is from up to down, you will make the current source like this. If the direction is from down to up, you will make the current source like this. Are you getting this point? Now, what is the interconnection between Thevenin's equivalent and Norton's equivalent? So it is a very interesting derivation or very interesting concept, I will say. So I will just interconnect both of them. So what is our Thevenin equivalent? This was our Thevenin equivalent, right? This is VTH, RTH, and R load. R load. This was our Thevenin's equivalent. Thevenin's equivalent. Now I will make Norton's equivalent. This is our Norton's equivalent. IN, RN, and R load. Right? This is our Norton's equivalent. Right? I will just keep them a bit up. Okay. Now what I will do, in this circuit, I will apply source transformation. Okay. I am applying source transformation. So how will I apply source transformation? This is current, in parallel to that there is a resistance. Current source, parallel there is a resistance. So I can replace it with the voltage source. And that voltage source will have a value of IN into RN. Okay. And this parallel resistance will come in series. And this R load will remain as it is. And this is R load. Let's just call this one as circuit A, this one as circuit B, and this one as circuit C. What did I do? This was my first part. Okay, this was my Thevenin's equivalent. This was my Norton's equivalent. I just applied the source transformation. Now can you compare circuit A and circuit C? Because both are same network. Okay, I was given a linear bilateral network. I converted it into Thevenin's equivalent like this. Then I converted it into Norton's equivalent like this. Now in Norton's equivalent, I applied the source transformation. So I got IN into RN in series with RN. Okay, and then R load. So can you compare circuit A and C? I will just add on a page. Comparing circuit A and C. What do I get? VTH is equals to IN into RN. So what do you think? IN is equals to VTH by RN, or RN is equals to VTH by IN. That is equals to RTH only. Okay, that is equals to RTH, that we will see in the next thing. So this is equation 1. Now also you can see that this RTH is equals to RN. We are just comparing these two circuits. VTH is equals to IN into RN and RTH is equals to RN. So the second equation that we got is RT is equals to RN. So let's just assume you are given a circuit and you needed to find the Thevenin resistance. Okay, so when you're doing the calculation, you got to know that finding Thevenin resistance is a bit hectic part. Okay, there are tough calculations or anything like that. So what you can do, you can find the Thevenin resistance there. Sorry, you can find the Thevenin voltage there. You can find the short circuit current there. Means Norton current there. You can simply divide those two, VTH by IN. You will get the RN value. So RN is equals to RTH is equals to VTH by IN. So now you know both of the theorems. Okay. So you can find any parameters getting only two parameters. You can find VTH and RTH. You can know what is IN and RN. Right. So there are four parameters: VTH, RTH, VN. Sorry, VTH, RTH, RN and IN. Okay. There are four parameters: VTH, RTH, RN and IN. You need to find any two, VTH or IN. You can find, you will get RTH and RN. Okay, so actually RTH is equals to RN only. So I will write RTH equals to RN and then you have IN. You can find the third parameter if you already know two of the parameters. If you already know two of the parameters. Are you getting this point? So this is how both of the models are related. That's why I said there is no difference between Norton and Thevenin's. Both are same only. By applying a simple transformation, simple source transformation, we got to know that both are equal only, right? So now we will see the questions. Okay. So before moving on to the Norton's theorem question or anything like that, I am just taking a simple reference question. You need to find the value of I in this question. Okay. So try it on your own. I will do a slight modification in this question. I will put this 2 volt equals to 4 volt. So yeah, now tell me what will be the value of I. So the reason why I took this question is that like many of the students will get it wrong. Let's assume this is ground. This potential will be 0. So what is the current here? The current here will be 2 ampere. So most of the student will say that this current source is between two short terminal. So this 2 ampere current will be flowing through the short circuit terminal. So value of I would be 2 ampere. Now this answer is wrong. Value of I is not 2 ampere. Just apply nodal analysis here. Just apply your nodal analysis here. 2 ampere current is coming that way. 1 ampere current is coming that way. Okay, the current source is short circuited. So what happened? No problem, because in the current source, I told you the definition of current source. What was the definition of current source? That it will always give 1 ampere current no matter whatever the voltage is there across it. Even if it is 0 voltage or even if it is 1000 voltage, it will always give you 1 ampere current. So there is 0 voltage across it. Okay. Still it will always give 1 ampere current only. So 2 ampere current is going that way, 1 ampere current is going that way. So total current I is 3 ampere, right? So if your current source is short circuited, still it will give the same amount of current. You always have to remember, okay? Even if your current source is short circuited, it will always give the same amount of current. So even if current source is short circuited, the current produced by this source will still be 1 ampere. So what will be the value of I? I will be 2 ampere plus 1 ampere, that means 3 ampere. Okay, 2 ampere coming that way, 1 ampere coming that way, so I will be 3 ampere. So many of the students get this concept wrong many of the times. So that's why I took this question. Now we will solve the real questions. So this question we solved with this. I am actually having high cold from yesterday night. So that's why I have to pause the video again and again. I hope this is not a problem for you guys. Okay. So yeah. So we have seen this question previously. We have to find the Norton equivalent across X and Y. We have found the Thevenin equivalent for this, right? But now we will find Norton equivalent. So how we will find the Norton equivalent? So what we need to do? Across the terminal X and Y, we have to short circuit. Okay. Now we will get the value of ISC. We need to find the value of ISC. Let's just assume this is 0. If this is 0, this will also be 0. This will also be 0. This will also be 0. This resistance is between 0 and 0. So that means there is 0 ampere current. This resistance is between 0 and 0. That means there is 0 ampere current. If value of I, that means value of I is 0 ampere. That means if this is 0, this will also be 0. So that means the current from here will also be 0 ampere. No current coming from here, no current coming from here, no current coming from here. Only current that is coming is ISC. That is ISC. That means ISC is ISC or IN I can call. That is 2 ampere. Look, if your resistance is short circuited, that means it will surely give 0 current. If there is no potential across the resistor, that means it will give 0 current. So 0 current, 2 ohm resistance, 0 current, 1 ohm resistance, 0 current. The current in 1 ohm resistance is I. So value of I goes to 0 ampere. That's why this voltage source also goes to 0 ampere. Sorry, 0 volt. So if this is 0 volt, this is 0 volt, that means in 1 ohm resistance there is 0 ampere current. So 0 ampere current, 0 ampere current, 0 ampere current. Only 2 ampere current is coming. So your short circuit current is 2 ampere. We have calculated RTH previously. RTH previously calculated. We have already calculated it. Previously calculated. Okay. So I don't need to calculate it again. So the value we get is 2 ohm. Okay. Because if VDC, IDC, we will put VDC here and get the IDC out of it. You will get the ratio of VDC by IDC. That will be 2 ohm only. Shall I do it again? Okay, I will do it again. Okay. If you have already seen it, you can skip this part. Okay. But here, this is a recorded course. So I guess I should do it again only. Okay. So I will do it again on this page. If you have already seen it, you can skip this part. Okay. Yeah. So how do you find RTH? We apply a voltage source VDC and get the IDC current out of it. Right. So if this potential is 0, you won't short circuit this time. Okay. If you short circuit, the RTH will be 0. Right. I hope you are not doing this thing. RTH is equals to RN only. Okay. RN is equals to RTH, that is equals to VDC by IDC. The short circuit thing will be done only for this. Just like open circuit thing was done only for Thevenin voltage. Okay. We just open circuit the load. Right. For finding Thevenin voltage only. So we short circuit the load for finding Norton current only. Okay. In case of Finding RTH, we are neither short circuiting it, neither open circuiting it, because we have IDC current here. That means we are not short circuiting it. Sorry, that means we are not open circuiting it. And we have VDC voltage here. That means we are not short circuiting it. So both voltage and current are there. Okay. So we need to find VDC by IDC. So if this is zero potential, this will be VDC. This will be gone. This 2 ampere source will be gone because this is a dependent source, right? And this will also be VDC. So here one thing you can see, VDC is equals to I, and then you can apply the nodal. VDC minus 2I by 2, so 2I by 1 plus VDC by 2 is equals to IDC. So am I missing something? VDC by 1 also I am missing, plus VDC by 1. VDC by 1 plus VDC minus 2I by 1 plus VDC by 2. So from here you get RTH equals to RN is equals to, this is equation 1 you can say, this is equation 2 you can say. So VDC by IDC you get is 2 ohm. Okay. So now you have the value of RTH as well, RTH and RN as well. Okay. So this is the value of RTH or RN. So you basically you have the value of IN, that is 2 ampere. You have the value of RN or RTH, that is 2 ohm. You can calculate the value of VTH as well now, right? IN into RTH, that means it will be 4 volt. Okay. So all 3 parameters you can calculate if you already know the 2 parameters. Let's move on to the next question. You have to find the Norton equivalent across AB. Norton equivalent across AB. Look, always finding Norton current is easier than finding open circuit voltage. I think so. Okay. Finding Thevenin voltage is a bit difficult than finding Norton current, because in Norton current you will just simply short circuit it. Look, I just short circuited it. Okay. Now what will happen? Let's just assume if this is 0, this will go to 0. This will also go to 0. What is the current here? 0 ampere. What is the value of I1? I1 will be minus 2 ampere, right? 10 minus 0 by 5. So I1 will be minus 2 ampere. But that's of no use, because from here we have 1 ampere current coming. From here we have 1 ampere current coming. And from here we have 2 ampere current coming. So this is my IN or ISC. So my IN is 3 ampere, right? 1 ampere current coming that way, 2 ampere current coming that way, and 0 ampere current this side. So my ISC is 3 ampere. That's it. Okay. Now you need to find RTH or equals to RN you need to find. So how will you find? I will just copy this circuit. So this was our circuit, and you need to find RTH, that is equals to RN. So first thing you will do is that you will just nullify the effect of independent voltage source or current source. This is independent current source, right? This is independent current source. You will simply open circuit it. This will be open circuited. This side is gone. Now this side is of no use. What you will do? You will apply VDC at this side and will get a current IDC out of it, right? You will apply a battery of VDC and get IDC out of it. Now just assume if this terminal is 0, what will be this potential? This potential will be VDC, right? And you will short circuit this terminal, right? You will short circuit this, because this is also a independent voltage source. So this will be also short circuited, right? Now this is also short circuited. So no need to apply VDC and IDC this time, because you can see across AB there is a 5 ohm resistance and there is a 5 ohm resistance. So basically RTH is equals to 5 ohm parallel with 5 ohm, that means 2.5 ohm. What happened to this? This is gone because this is open circuited. What is the current in this terminal? 0 ampere, right? Because this is open circuited. So 0.55 is gone. So across AB, what do I see? Across AB, what do I see? 5 ohm resistance in parallel to 5 ohm resistance. So total 2.5 ohm resistance. So my RTH is 2.5 ohm. So my IN was 3 ampere and my RTH that is equals to RN that is equals to 2.5 ohm, and my VTH I don't need to write, or you can see what will be VTH. VTH will be 7.5 volt. Now I will make the equivalent circuit. How will the equivalent circuit look like? Like this, because the current, because ISC current was going this way, downward. So I will make the current source upward. ISC was going downward, so I will make current source upward. Okay. So ISC was 3 ampere. Then I had a parallel resistance of 2.5 ohm and a load resistance, not a load, but two terminal A and B. I had two terminal A and B. Okay, so this is my Norton's equivalent. Okay, are you getting this point? Well and good, very easy. Let's move on to the next question. You have to find VTH, RTH and IN. All three things you need to find. Across what? Across AB. Okay, across AB. Let's just call this is A, this is B. IN across AB. Okay, so how will you find it? So what should we find first? We'll find VTH, RTH first. Okay, so we will find RTH first. So what you will do? Short circuit this and short circuit this, open circuit this. All are independent sources. You will short circuit this and open circuit this. So what will happen? Can I write it directly? If I short circuit this, 2 ohm will come in parallel. So I will see 1 ohm resistance here across A, 1 ohm, right? Because this 2 ohm will come in parallel. Now this is my node B, because I am finding my equivalent resistance across this, right? So I will open circuit this. I am finding equivalent resistance across 1 ohm resistance. Okay, so across 1 ohm resistance, so I will forget 1 ohm resistance. The rest of the part I need to consider, right? And this 2 ohm will come here. And from here I am seeing my RTH. So what is my RTH? Both will come in series, right? So RTH will be 2 plus 1 equals to 3 ohm. Is anyone having any doubt like why 1 and 2 ohm are in series? Just A and B, there is a voltage source. Just connect a voltage source across A and B. There will be some current flowing. That current will be I. So the same current will be flowing through 1 ohm and the same current will be flowing through 2 ohm. A and B are connected like this. There is 1 ohm resistance here, 2 ohm resistance here. Both will come in series only. Right? 1 plus 2, 3. So RTH is 3 ohm. Okay. Now what we will find? We will find VTH. Let's just find VTH. Again, I need to add a page. What is VTH? VTH is a open circuit voltage. So here I have a 20 volt battery. I will not do anything with that because I am finding VTH this time. So I will not do anything with that. I have a resistance of 2 ohm and 2 ohm. 2 ohm and 2 ohm. Then I will just open circuit the load. Then I have a current source here. I have a resistance here. I have a battery here. Battery of 5 volt, 2 ohm. 5 volt, 2 ohm and 1 ampere current. This is my node A, this is my node B. I need to find VTH. I will find VTH like this. Here I am finding VTH. Okay. What is my VTH actually? Potential at node A minus potential at node B. Is it my VTH only, right? What is potential at node A? Both of them will come in series because this is a open circuit node now. Node A is open circuited, so 2 ohm and 2 ohm will come in series only. So VA will be 10 volt. Simply potential divide. What will be VB? If this is 1 ampere current, there will be no current at this side, right? because this is open circuited, because VTH is open circuited voltage. So no current will be having in the node B. So this complete 1 ampere current, will be flowing that way. That will give a voltage drop of 2 volt. Complete 1 ampere current will be flowing that way. That will give a voltage drop of 2 volt. That means your VB will be 5 minus 2. That means 3 volt. So your VTH will be 7 volt. Are you getting this point? How did I calculate it? What did I do? I just open circuited the load. I need to find VTH. So my VTH is VA minus VB. What is VA? 10 volt. What is VB? 5 minus 1 ampere current is flowing that way. 5 minus 2. That is my VB. I should have written here, like many of the students will get confused. What is VB? 5 minus 2. So 10 minus 3, 7 volt. That is my VTH. If I am drawing my equivalent, let's just draw the Thevenin equivalent. Thevenin's equivalent. So what should be the direction of the voltage source? That is a major part. Okay. So if I am making my direction like this, if this is my 7 volt, what was my equivalent resistance? That was 1 ohm, right? Oh, sorry, 3 ohm. Equivalent resistance was 3 ohm. So at positive side should be given to node A, right? The positive side of battery, because I have written VTH equals to VA minus VB. So the positive side of battery should be given to node A. Okay. So if I am arranging my resistance, that was 1 ohm resistance. This was the 1 ohm resistance. So this would be my node A and this would be my node B, and this would become 1 ohm resistance. Did you get this point? If I am writing VTH equals to VA minus VB, that means the positive side should be connected to VA and the negative side should be connected to VB. Are you getting this point? So the sign convention is very much important. Okay. Now we will find Norton equivalent. So for finding my final Norton current IN, I will not do anything with the independent sources or even with the independent sources, because this is the Norton current, right? So I will not do anything with those. So they were 2 ohm and 2 ohm. This was my node A, this was my node B. I had current source of 1 ampere here, right? And then I had a voltage source of 5 volt here and a 2 ohm resistance, and a 2 ohm resistance here. What I will do, I will just short circuit this. And this is the current I am finding. I am finding the current from A to B. Okay. So how will I make my equivalent actually? It will be like this: ISC, RN. The current should enter into path A. Sorry, node A. The current should enter into node A. Current is entering into node A and getting out of node B. So this is how my circuit will look like. This will be node A, this will be node B. Okay. This will be my IN, and this will be my RN, and this will be my 1 ohm resistance. Are you getting my point? How am I writing the direction of the current source and or the voltage source? Voltage source, positive terminal, that side, that means A should have the positive terminal. Similarly, A should have the current getting into it and B should have the current getting out of it. So the current is getting into the node A only. So that's how I am making my direction. Okay. And that's how you need to make the direction. Now you need to find the value of ISC. You can find it easily, I guess. Simply by nodal analysis, I guess I can find. Or what I can do. Or actually I have the parameters VTH I have and RTH I have. So ISC would be 7 by 3. That I know, already know. ISC would be 7 by 3. But let's just find by nodal analysis. Let's just assume this is my potential V. So V minus 20 by 2 plus V by 2 plus 1 ampere plus V minus, if this is V, this will also be V, plus V minus 5 by this is V, this will also be V plus V minus 5 by 2 is equals to 0. So it will be 4V, it will be 3V minus 25 plus 2 minus 23 equals to 0. Am I doing the right calculation? 3V minus 18 minus 5 23 so V value is 23 by 3 volt, 23 by 3 volt. That means I am having 23 by, or I can forget about this, I can write the current in this path. So my current would be, let's just call this current as I dash. So my I dash current would be 5 minus 23 by 3 by 2. It will be 15 minus 23 by 6. That means it would be minus 8 by 6 minus 4 by 3 ampere. That means I am having 4 by 3 ampere current that side, right? 1 ampere current that side, 4 by 3 ampere current that side. So what will be the value of ISC? So value of ISC would be 4 by 3 plus 1. That means 7 by 3 ampere. So this will be my value of ISC. Okay. Very easy calculation. Nothing is difficult. Simple network analysis. I just needed to find the value of ISC. What did I do? I found the potential. I found this potential. If I have this potential, I know this current. Then this current came out to be 4 by 3 ampere that side. 4 by 3 ampere plus 1 ampere. That means this is my ISC. So ISC is 7 by 3 ampere. That's it. Okay. So I know the value of ISC, that is equals to IN only. Okay. So IN is equals to 7 by 3 ampere and RN is equals to 3 ohm and VTH is equals to 7 volt. Okay. So this is the equivalent circuit. So I hope you are getting the concept of theorems now. Superposition theorem we have seen, Thevenin's theorem we have seen, Norton's theorem we have seen. I will just revise it once again. What is superposition theorem? Consider only one source at a time. Keep dependent sources intact. Nothing will happen with dependent sources. Okay. Independent sources you will consider only one at a time. Get the parameter, add them up. That's it. Thevenin's theorem. You have to find VTH and RTH. For RTH, apply VDC and get IDC out of it. You will nullify the effect of independent voltage source and current source. You will do nothing with the dependent voltage source and the dependent current source. Only independent current source will be nullified. Okay. And while finding the VTH, do nothing with the complete circuit. VTH is simply open circuit voltage. Apply VTH there, find the value of VTH. And from that node, there is zero current because VTH is open circuit voltage. While finding ISC, what you will do? You will just short circuit it. Okay. You will just short circuit the load and get the final current out of it. Don't do anything with the circuit. What is RTH and what is RN? RTH is equals to RN only. I have told you the method of finding RN as well. Okay. And RTH as well. Now, what is my Thevenin equivalent circuit? Thevenin equivalent circuit is VTH in series with RTH. What is my Norton equivalent circuit? IN in parallel with RN. That's it. These are the three most important theorem and this is the complete conclusion. I will see if I have any other question left. Okay, some basic information I will give out ideal transformer because it will be used in assignment problem. Okay, so let's just see the information. Okay, so transformer, one thing is that just like resistor, just like capacitor and just like inductor, transformer is also a linear element. So in the initial days, like people get confused between transformer and transistor. Like in the initial days, let's just assume you are in first year or second year of BTech. So like they interchange the terms like transformer and transistor. Sometimes they call transistor as transformer. So both are a very different thing. Okay, so transformer is also a linear element. Okay, transformer is also a linear element. Okay, so in transformer there are basically two windings. This winding is called primary winding. Okay, and this will be called secondary winding. Okay, in two-port network as well, you will be given this concept. Okay, in two-port network as well, we will see the concept of transformer yet again. Okay, we will see the concept of transformer yet again in two-port network as well. But here I am also giving the concept. Okay. Now, what is N1? N1 is the winding number of windings in primary coil, I can say. And what is N2? Like EC student don't need to study this topic very deeply. Electrical student will study this topic very deeply in electrical machines, but we don't need to study it very deeply. Okay. So what is N2? N2 is the number of winding in secondary coil. Okay. So I am having a high cold actually. I have to pause it once again. So at primary winding you are having a voltage V1, and at secondary winding you are having a voltage V2. This is your voltage V2, this is your voltage V1. At primary winding voltage V1 and secondary winding voltage V2. So what is the ratio of V1 and V2? V1 by V2 is N1 by N2. Okay. This is first thing you need to remember. And the second thing is, what is the ratio of I1 by I2? Okay. Just notice the direction. This direction is I1. I2 direction is not like this. I2 is like this. Okay. This is I1 and I2 is like this. Okay. I1, I2. Always notice this. This is the most important part. Okay. I2 is going inside the V2. Okay. So many of the time students will make I2 like this. So this is not I2. I2 is this. So I1 by I2 is N2 by N1. Okay. So these two things you have to remember. That's it. Nothing else. We will also see how to refer the resistance, but that we will see in two-port network. Okay. For this part, for network theorem, you only need to consider these two things only. V1 by V2 is N1 by N2. I1 by I2 is N2 by N1. Keep notice of the current direction. Current direction is outward, not inward. Okay. So we will solve a question regarding it. Then you will understand why did I give this concept here. Okay. So some basic information you need to know about ideal transformer, not transformation. Okay. So in the next video, I guess that's it. Yeah. In the next video, we will see assignment 6. So there are very less problem, I guess. So I will just show you the problems. This is the first problem. Okay, we have to find Thevenin equivalent across terminal X and ground. Here you need to find Thevenin equivalent. Okay, you have to find the current I. Like people will think this is a very easy problem. Why I have given here? Yeah, this is very easy problem. You can get the final answer very easily. But I will give you one concept here. Okay, so you have to find the current I. It will be this problem will give you a very good concept. So that we will see in next video. You have to find Thevenin equivalent across AB. Like this is the question on transformer. Okay, you have to find Thevenin equivalent across AB. These are AB actually. In the previous question I marked AB. Yeah, AB is marked. In this question you have to find Thevenin equivalent across X and Y. Sorry, Norton equivalent across XY. In this question also I will give you a very interesting concept. Okay. Now we are revisiting the concept of linear circuit once again. So like this concept will be used to solve further problems. So I can just tell you one thing, that in linear circuit all the parameters are linearly dependent. Like V3 will be linearly dependent to V1 and V2. I1 will be linearly dependent to V1, I2, V2, V3. So all the parameters are linearly dependent. That's the only concept. Okay. So based on this concept, we will be solving these questions. Like when V is 15, I is 10 ampere. So when V is 90, what will be the value of I? What do you think? What will be the value of I? If this is 6 times, this will also be 6 times. So it will be 60 ampere. So this is how you need to solve the linear passive network. Okay. So these kind of question you can solve. Okay. This question you can also try. And then this question you can also try. Then this is a simple question on Thevenin's equivalent. And yeah, that's it. So these problems are there. This problem, this problem, this problem, this problem, this problem. So all the problems I have shown you. When you come when you come to watch the next lecture, you should be done with the assignment on your own. Okay, so let's meet in the next video. Okay, thank you.